Is this good? I guess.
That can be on if you want it to be.
If everyone can hear me already, then I'll speak like this. Okay. So I'm sorry for the very nerdy introduction slide. As you can see, I'm going to be talking about Python versus R for data science. I have a background in computer science and neuroscience. I started using Python when I was doing some research projects for my neuroscience projects, and I started using it to program some experiments, and then I started using R to analyze the data that I collected after conducting those experiments. So I stick to R, Python more since I started using Python first, and recently I realized that I should have actually learned R more because it fits the type of analysis I want to do better. So that's why I'm here, and I'm trying to learn more R. So I'm going to display some code at the end. If you have any feedback, I'm not the most proficient person in R. Just feel free to criticize my code. I thought it's a good idea to start with some historical information because the history of these two languages already will give you an idea about their strengths and weaknesses. R was created by statisticians, two academics working at the University of Auckland in New Zealand in 1995. As both are statisticians, the purpose was to deliver a better and more user-friendly way to do data analysis, statistics, and graphical models. Python, on the other hand, was created by a computer scientist in 1991, and the focus was more on code readability and ease. So the history already tells us that R has more strengths in statistics and data visualization, and Python has more strengths in automation and data manipulation. So as I was going through, and as I Googled to get more information about what people think about R versus Python for data science, I came across some fun facts. You can also call them speculations because I don't know where they get that data from. But according to DataCamp, the popularity of R is on the rise since 2013-14, whereas the popularity of Python has been decreasing. And they even have salary information. I don't know how they got the data, but they claim that the R programmers seem to make more money than Python programmers. I also got some information from KD Nuggets. Based on their polls, the number of R users is higher than the number of Python users. They also claim that there are more Stack Overflow questions tagged R compared to Python, but here they separate pandas and NumPy. I think it's a little hard to read, but I think it's a little cheating. If you combine NumPy and pandas, probably Python is going to get closer to R. But nevertheless, they seem to think that R is leading when it comes to Stack Overflow questions. This might mean that there are more R users, but it could also mean that R users just have more questions. They also claim that there are more tweets from R users. But if you check the Google Trends, the tide is turning. So since 2016, Python data science seems to be leading. But if you check this data more closely, if you separate machine learning from data science, Python seems to be leading, especially when it comes to machine learning. For other types of data science, Python and R seem to have similar strengths. Although, which one is more popular depends who you ask. Both communities seem to agree on certain factors. And I tried to summarize all of them in this table. So both Python and R communities seem to agree that it's a little easier to learn Python because if you think about the history, it was developed by computer scientists. And the goal was to develop a computer science language that's easy to read. So people seem to think that R has a steeper learning curve. As it was developed for statistics and visualization, R seems to have better visualization capabilities, but I think with the new packages, Python is catching up with R. When it comes to community support, both languages seem to have a very active and big community. When it comes to deep learning libraries, people seem to favor Python. I think it's because deep learning has been a greater interest of computer science community, but I think it's becoming more relevant to statistics as well, so this might change in the future. People seem to prefer Python for data wrangling as well. I think this is mostly due to the pandas package. When it comes to speed, people think Python is faster, but in the end, if you just want to do ad hoc statistics, if you want to do some data visualization, you don't want to do complicated machine learning, people seem to favor R. I thought it would be interesting to compare these two languages using some hands-on examples. So I'm going to try to use the exact same data set in R and Python and do some visualization with heat map. And then I'm going to try to do linear regression using lasso regularization. And then I'm going to do some simple machine learning using k-nearest neighbor classification. And I'm going to time my code in both languages, and we're going to see which one is faster.
This is awesome in some ways.
Well, I have to say
I know who wins.
Can we make bets?
Yeah.
That would be
Yeah.
awesome. We should have
Any
had
bets?
betting.
I have to say that, I tried to program these two analyses exactly the same way as much as I could, but it's not actually possible to do everything exactly the same in these two languages. So, and I'm not as proficient in R as I am in Python, so it should, after the class, we're going to put this on, it's already on GitHub, we're going to put it on the Meetup webpage, so you can just go to my GitHub and try to play around with it yourself, and maybe there are better ways to, and faster ways to actually do the same thing. I'm not going to go through each and every line of code because that's going to be really long and boring, but if you have any questions, feel free to ask. You can also, as I said, play around with it later yourself. In both languages, it's pretty easy to time your code. You start a timer, like with one line of code. I decided to use the Iowa housing data set, which is a public data set that has information about different features of houses in Iowa region and the sale price for each house. So it has features like number of bedrooms, number of bathrooms, lot area, the neighborhood, and the sale price of that house. The data set itself is actually not so clean, but I found a clean version. So but if you want to play around with that data set, I put it online as well, but you have to change the packs, obviously. If you want to visualize the first 10 rows of your data, it's pretty straightforward in both Python and R. You can just say head your data set and the number of your rows you want to visualize in R. And again, you can just use your data frames name .head in Python. I've been using R Markdown for R and Jupyter Notebooks for Python. I find the way Python displays this information a little nicer. You can just scroll and see all your data in Jupyter Notebooks, whereas in R you have to scroll down, which is a little dirtier, but in both languages you can easily visualize your data.
I think you can use, I'll be nitpicky, in R you can do the same thing if you use Panda or Table.
Okay, so
What is it called? So there's Pander is a package for generating for HTML tables like this. And then I can't remember which table is also a function of knitter, which will allow you to display also.
That scrolling thing, that's a feature of Jupyter Notebooks, not a feature of Python itself.
yeah.
Exactly, yeah. You can also run R in Jupyter.
You can try around all these, but yeah, I did it in one way, but this is just an example, and you should definitely try to improve it. But thank you for feedback.
This is
Yeah.
awesome, I love it.
Yeah, this is,
Yeah. I'm gonna try to do some heat map visualization. So the data set has many features, like I mentioned, and some of the features are categorical, some of them are continuous. To make it easier, I just picked 5 numerical features to display the heat map. If you use all of them, it's just you can't read anything. I decided to use a lot frontage, lot area, number of bathrooms, number of bedrooms, and the year the house was sold, because I thought these are more relevant to sale price. But you can play around with all the other parameters as well. I'm using the ggplot library in R. I'm going to use the Seaborn package in Python. In R, I think the difference in readability is easily seen here. In Python, let's say you have no idea about Python, you don't know the syntax, you don't even know how to program. Once you read this line of code, you have an idea about what it's trying to do. It's trying to make a heat map. Whereas in R, you have to know what ggplot is doing more or less to understand what you're going to get out of this code.
Does the period have a meaning in Python?
Same thing as Python.
SNS.heatmap?
Subclass.
Okay.
Thank you.
Yeah, sub-object.
Yeah, it's not the same.
Well, it kind of depends on which dot that she's asking about. So, which dot is it? The SNS dot?
Yeah.
SNS, is that the
Yeah, it's
package
the
name?
package.
Oh, it's the package
it's
name. I
Seaborn,
see.
Yeah, it's the name of the package.
So, like how you would do.
But she also did it earlier with an object, right?
Right,
And a
so-
data table, and then there,
Here?
train data head.
Yeah.
So, and if you, since Python is a more object-oriented language, if you have, like objects can have methods that are associated with that method, with that object. So like for the one that's dot head, it's saying that pandas object has a function called head that you can apply to it, and it will be the same thing as that object piping into head function.
Okay.
R works that way. R works in a way where you don't have to specify the class, and it just tries to match it as best as possible. And you can kind of see that from the import Seaborn, because Seaborn is a library, as much like how R will be like library ggplot. But in R, you don't do ggplot2 dot ggplot to call a function ggplot in the library of ggplot2. You just call ggplot, and R reconciles the names for you. And that's the design of the language.
Or has a lot of conflicts.
Or I have a lot of conflict, but it generally is pretty good at finding the right one. But in Python, you can say Seaborn, and if you do dot as SMS, you're kind of abbreviating Seaborn, because you might not want to write Seaborn all the time. But if you didn't have the SMS, you can do Seaborn.heatmap, because heatmap is a function within Seaborn.
Yeah, as you can see it in the beginning as well. We are just using head for R and data dot head for Python.
Oh, I see. So dot head for Python, you can do your object dot head in Python because head is a built-in function for Python. It's not dependent on any package like pandas or Seaborn or something
I mean,
like that.
Train data is a pandas object, so I'm not sure if it would work with
Yeah, it's,
other types of objects. I think it has to be a pandas object. But.
Okay.
So going back to heat maps, although I find the syntax of Python more intuitive, I find the output of R nicer and easier to read. Although the output Python gives is fine as well. It's just because R uses one coloring by default, and I find it easier to just like, based on the brightness of the color, you can already understand the value of the correlation coefficient, whereas in Python there are too many colors for my taste. But you can change the coloring easily, actually. Now I'm going to try to do some regression analysis. So here I'm loading the packages as I go. Normally, by with coding standards, you should load all your packages in the beginning of your code, but this is just to make it comparable with each other. I'm going to use glmnet package in R, and I'm going to use the scikit-learn in Python. I'm going to try to do lasso regression, which basically is a linear regression method that regularizes your data to overcome overfitting, and it also assigns the weight of 0, or assigns a coefficient of 0 to not so significant features in your data set, so it can also be used for feature selection. So even if your end goal is not to do regression, you want to do some machine learning, I use lasso regression at least to do feature selection before I go on with my machine learning. In Python, you can split your data set into test and training data sets easily with train test split, which comes from the scikit-learn. In R, I had to do it a little bit more manually. Maybe there's a better way though, but that's what I could find. In both, I first do some cross-validation to get the best penalty parameter, and then I train my model. In R, you have to first train your model and then do the prediction. In Python, to get the coefficients, you don't actually need to do the prediction. You can already get the coefficients if you do the training. And when I display what kind of coefficients R and Python assigned to my features, the result is actually different in these languages. I'm not sure why. This puzzled me, but if you try to plot the coefficients that it assigns, the functions assigned to each feature, you can see that the ordering is the same in both languages. And it's really easy to plot your coefficients in R using just plot MO package and just using the function plotgl.net, and it displays the coefficient it assigns to features as a function of the lambda parameter. So you can see that R thinks the number of bathrooms is the most important parameter to predict the sale price, which I find a little surprising. And the number of bedrooms is actually, it has a negative coefficient, which is, I mean, I think it's important when you're trying to buy a house, but there might be some collinearity in the data as well that you should pay attention to normally. And Python seems to think that the number of bathrooms is still the most important parameter. Then comes a lot frontage, lot area. So the ordering is exactly the same in these two languages, but the coefficients they assign is different. Finally, I'm going to try to do some simple machine learning using KNN, so K nearest neighbor classifier. I'm going to use the caret package in R and again scikit-learn in Python. Both packages come with the iris data set. So using a continuous data set does not make so much sense for the classification problem. So I decided to use a different data set for this. We talked about the iris data set in the last meetup, but anyone is not familiar with it, it's a public data set that has like information about the visual features of flowers and the species of that type of flower, basically. So the parameter that we are trying to classify is the species, and I think it has 3 different species. Both packages have the iris data set. Again, you can do the train test splitting in one line of code in Python using the train test split package. I'm going to use 70% of my data as the training set, 30% of my data as the test set. You can do that in R easily as well using the create data partition. To do the KNN, you need like 2 lines of code in R, and as I mentioned before, the syntax is not so obvious. So the method is only specified here. If you check here, you see that I'm trying to do KNN classification, but like just by the name of the functions, it doesn't tell me that I'm trying to do KNN classification. Whereas in Python, the name of the classifier is kneighbors classifier, which you can see here. So even if you have no idea about Python, this would tell you a lot already. One good thing about R is though it does the scaling within one line of code. So if you pass this parameter and ask it to scale your data, so normalize your data, you can do it just within the function itself. Whereas in Python, you have to use 2 different steps to normalize your data. And in R, it's very easy to get the accuracy values as a function of the number of neighbors the algorithm uses. So if you just print the output of the training step, it gives you the accuracy values for each number of neighbors, and it also ranks them. So the number of neighbors that gives the best accuracy is 5. in Python, as far as I know, to be able to check the accuracy values for each number of neighbors, you have to do it manually, you have to do a for loop. If anyone knows a better way, you can speak up. One interesting thing is that if you don't do cross-validation, which probably tells us that it's overfitting, but Python comes with a higher accuracy value. If you do cross-validation and take the mean score, then Python and R seem to give the same accuracy values, which is around 4%. And the results of our timing. So once we are done with programming our code, we can stop our timer. And all these steps take around 6 seconds, whereas Python does all these in around 2 seconds. But like I mentioned, I'm sure there's a faster way to do this in R. You should play around with it on your own, and if you find the faster way, let us know. I want to talk a little bit about my own experience using both Python and R as well. I have a background in computer science as well. And as a computer scientist, I do find Python's syntax more intuitive. It's more similar to other programming languages, whereas R syntax is a little different, coming from a computer science background, but it's still very easy to learn. I think you just need to know the differences, and then if you overcome that first steep learning curve, then it's super easy to use that as well. Recently, I realized that it's actually way easier to use R for data visualization, simple regression, and especially for business analytics, like doing conjoint analysis, and R is way easier than in Python. And this is what I'm trying to do, so that's why I decided to learn more R. And in my experience, Python also sometimes has nerve-breaking bugs, mostly related to compatibility issues. If you have different versions of Python, they mostly don't have compatibility with each other, so if you want to update your Python, you mostly need to update everything on your computer. I even have to uninstall everything, install again. I haven't experienced that with R, but I haven't used it as much either. So to conclude, I would suggest using R if you mainly want to visualize your data, just get some idea about the trends in your data. Your data is relatively clean, and your main goal is to visualize, and you don't want to do fancy machine learning or deep learning. I think it's better to use Python, and most Python-based positions actually ask you to be kind of a full-stack engineer as well. If you want to, in the end, interface your code with a web-based system, and there are many web frameworks that allow you to do that in Python. There are some in R as well, but I think it's more common to do that in Python than in R. If you need to do a little data wrangling, after which you're going to visualize your data, you can clean your data with Python and then visualize it with R, so you can use both if you want. And probably this is a crime for a data scientist, but if your data is really small, you can even use Excel. And sometimes I realize I spend too much time trying to program it, but I could do the same thing in Excel in probably 10 minutes. So always pay attention to the size of your data. Yeah. And that's it.
Maybe you'll post a GitHub. Will the GitHub link be posted in a meetup, or what's a GitHub link, Sita?
Oh yeah, I had it in one of the slides.
Yeah, we'll
It
post the
passed it.
slides
Yeah.
and all the materials. We can put it on the meetup and then also on the other places.
I copied it twice. It's just long ago.
Yeah, we'll put it in
Yeah.
in the meetup.
Yeah, I mean, I think the code part was a little too fast, but I think it's very hard to go line by line. You have to do it yourself. So I hope it was still helpful.
It was great.
This is so cool. I've never seen the side by side like that
I
or
know.
something.
Yeah.
It was difficult actually. I realized it's super difficult. That's why I tried to use R Markdown and Jupyter. Then you have
Yeah.
all the comments. They're the same, so I know what to do.
Yeah,
Otherwise, it would get lost.
Cool. And I'm curious, what was the hardest? So did you do it first in Python and then you try to do it in R? Or did you really try to do it in parallel as you did it?
I actually first did it in R because that was gonna be more difficult for me.
Yeah.
And I could easily translate it into Python. But if you're, I think, more like proficient in R, you can start with doing in Python and then with an R, but like, would you do that? Unless you want to present something like this. Yeah.
Cool. Does anyone else have questions? Ideas?
I looked up, so if I was splitting into a training data set, I'd do exactly what you do, but I thought someone must have written a function for that. There's a function called create data partition in the Caret package that does it.
Yeah, I
you
used
try
that when
this?
I was doing the machine learning, but when I was doing the regression, I did not because I was not using the Caret
Oh,
package.
because you hadn't loaded the Caret package.
Yeah, but
Okay.
I mean, you can as well use that, I guess. Yeah. So, thank you.
I'm curious, how many people here use Python? Okay. And then everybody else uses R? Okay. I'm just curious, this was so cool. I'm gonna